interlocks in high voltage vehicles. So hybrid electric vehicles, fuel cell vehicles, doesn't make a difference, you find them everywhere. Hello friends, welcome. We are here today with a new video and we're gonna talk about interlocks. On my side again, my good friend and colleague Daniel. Good to have you back, finally.
It's been a while.
Let's dig ourselves with you together into that topic. You see here a bunch of different manual service disconnects which Daniel brought with us. And we have our Unitrain system here, which is basically showing the high voltage system or the different three parts of a high voltage system of a vehicle. So we're talking about the high voltage battery, the inverter and the electric motor. And where you directly see the link between the real world and the training system is our orange plug here. So the MSD, the manual service disconnect, we have here the big guys and here our small guy. All right, mate. Interlock.
Yeah, so it's a very important component when it comes to safety within hybrid and electric vehicles. So as you mentioned, it's a component that allows basically the controller, whatever you want to call it, there's lots of different names. So there's the ECU, the control module, the BMS, whatever the component is that is overlooking the system. This allows the computer to identify that someone has essentially tried to open a component of the vehicle, a high voltage component of the vehicle, and that will immediately shut down the contactors or the relays that are transporting the high voltage to or throughout the vehicle.
So the interlock basically, when there's now coming a guy and it says, I haven't seen an interlock. So how would you explain that to a person then? How can I see the interlock? Because basically the interlock is hidden inside the vehicle. It's not like that you have a obviously point where it's coming out, except those MSD switches here. But basically, it's like a network running through the whole high voltage system, right?
Yeah, absolutely. So there's a couple of different things that we'll show here. So first of all, we've got real connectors from vehicles. So this is from different training systems that we're working on right now that are going to have some real components on there like this. So as you said, this is the DC cable that would, for example, come from the battery to the inverter.
This is why I just have two cables?
Exactly. Very good. Pick that up well. Two cables, DC.
Thank you.
If it's coming from the inverter to the motor, of course, we'll have three cables as well. Got a little one here for the AC. It's just got some test cables in there now. That's why they're
that would be the question. No, so normally it would be orange as well.
Absolutely.
Everything high voltage will be orange or is orange.
Absolutely. So anything above 60 volts DC, 30 volts AC will be orange. Or as you mentioned, manual service disconnect. So these manual service disconnect is the modern name for this. Started out being called a service disconnect. And this is a typical example from the older ones that you see from Toyota. And
or Audi.
Or Audi, this one exactly from Audi. Some modern ones that you see here are a little bit different, a little bit bigger. This one, for example, is from a truck that you see. This one here is actually called a mini manual service disconnect, even though it's quite big. And this one here is also for light vehicles, but it contains a large fuse.
Even if it doesn't see really light, so it's a pretty tough guy.
Exactly.
But basically you can say everything it has all the same intention. It doesn't matter how different those things are looking. It's like on the one side, they carrying the high voltage, so the high current basically, not the high voltage. And on the other side, they have the small connection for the interlock, right?
Exactly. So, and it's not always just the high voltage components as well. So obviously, the point is that if someone opens something, so in this case, it's the cables or the connectors carrying the voltage and the current. If someone tries to open that, it'll immediately shut it down. Sometimes you often see it in the low voltage section as well, but this will serve the same purpose. So this is obviously just a connection without the cables on it, but this is what we see now is a low voltage service disconnect. And this one here is also a part of the interlock, but it's not containing the high voltage itself. That's why the green as opposed to orange.
There is a good little story on that side. So this guy here was at the BMW i3, when you go back in time, the very first versions. I'm pretty sure BMW used the orange one here as well. And so that led to high confusion, as the people thought, oh, when it's orange, it is high voltage, but it is not. So this guy doesn't have to do anything with high voltage. It just is bearing the interlock, and that leads to shutting down the high voltage system.
Exactly.
And just at this point, shutting down the high voltage system doesn't mean to discharge the high voltage battery, all right? It just means that we disconnect the high voltage battery from the rest of the high voltage system.
If we have a look on our within our LabSoft course for this unit, we also have a couple of examples where the interlock is on a cover. So here it's a part of a current carrying system, so the cables or the manual service disconnect. But in this case here, we actually see that it's just a bridge connector that is a part of the cover. So this, what we're seeing right now, is from a Toyota Prius.
3.
And right on the end here, we can see this little connector, and that's our interlock. And the bridge connector was on the cover. So when you take the cover out, you actually are opening that bridge connector.
And you interrupt the interlock basically. So the goal is always that when you open something, you interrupt the interlock before you are able to touch anything which has to do with high voltage.
Absolutely. So on this other example here on the BMW i3, if you have a look right here, there's also another little plug. You need to disconnect that before you can slide the connector out, which then allows the connector to come apart. Same on Volkswagen, had a similar system.
So it's like a mechanical lock there in that case. You cannot open the switch as long as there is this physical block, let's say that way.
And they often integrate that into a lot of different connectors that you find in electric vehicles. It's not simply just being able to disconnect it. It's, it's trying to make it as obvious as possible what you're doing.
Yeah.
So, for example, with the different connectors that we see here, so it's partly open right now, but there's a multi-stage connection to this. So you have to pull this section up first. So if you try and pull it up, that's the first lock. Pull it up to here, and that's also locked again. We have to sort of push down on the connection underneath, get it up, and then we can undo it here.
But this task you always have to do with your safety gloves, right?
Absolutely. So it gets pretty tricky when you're wearing big fat gloves as well. Leather gloves and rubber gloves.
Exactly.
Leather gloves on top of your rubber gloves.
That was my idea.
Rubber gloves.
So, but don't worry, like we said, this is not high voltage, so you don't need to wear your gloves here. So that would be quite challenging to get this guy opened or closed with insulation gloves and the leather gloves on top of it.
Exactly. And what it is that we're actually looking for is, if you take a look inside the connection right here, there's obviously there's a plug on this side, and here there's 2 pins on that side which go into the plug in the middle there. We can also see on the outside of that plug the 2 big contacts that they're obviously where the current's going through. So we can see that. That's the main advantage of these types of service disconnects is they not only disconnect the battery, so this is kind of splitting the battery into 2 halves as well.
Okay.
So let's say the battery is at 400 volts.
Yeah.
This will split the battery into 2 halves. Some do it roughly 2/3 of the battery and another third on the other side. Some do it in halves as well.
I think a famous example is Toyota Prius 3, where they did it like 1/3, 2/3 when they split it up, so not directly 50-50. What's also interesting when we have a look on those MSDs, so where we see, for example, what high current is flowing over it or how different it can be. So this guy, for example, over here, we have 550 amperage.
Exactly. If you think about a vehicle, it takes a huge amount of current for them to drive. So we've taken some measurements of the vehicles, and the current goes up. Back in the day, huge amounts. And what's interesting between these two, as you can see, there's a weight difference and a size difference, and then also the amperage is different as well. Difference was this one had a fuse in it, this one doesn't have a fuse in it as well. So that's why this one has a lower amperage.
Okay, I see. So, and can you also say, where are those? So we said we have also things which are used in light vehicles, and we have those MSDs who are used in commercial vehicles, for example. Can you see it now, or you just have to know it? So which example, or where do you find here an example which is used, for example, in a truck, in an electric truck?
Yeah, well, this one here, for example, is from an electric truck, and you can see the voltage on this one is 1,500 volts. And that's also using pretty large, hefty contacts in here as well.
Yeah. So do we have the chance to see the interlock from the inside somehow?
So not really. Sometimes within a scan tool you can measure the voltage. There'll be a point somewhere within the circuit where you can measure the voltage, and that's how it determines which of the connectors is open, because each of these has their own designation. I'll show you in a second what that looks like. But essentially what's also important to understand is that each of these connectors, the interlock is the first thing that will open, because obviously we want to avoid opening a high voltage circuit when current is running through it.
When we're just looking at the amounts of current here, that would create a massive spark, I guess, huh?
Exactly, and that's what you read everywhere is about arc flash protection. So, some famous videos out there, and obviously that's when a connection or a conductor is pulled apart while current is flowing through there. If it's high current, the current will want to continue flowing through, and that's when you get an arc flash, and that's when you can really hurt yourself. So
this way you find a couple of videos on YouTube, so just Google for that, but also in our car train courses, there we also have pretty cool videos which are showing what can happen there.
Exactly, and it's part of the reason why you wear a face shield and full body protection when working with high voltage. So anyway, but the first thing we do here is you need to pull it out, which disconnects the interlock connection right here.
And this is of course no problem, because there we are just disconnecting like 5 or 12 volt.
Yeah, well, it's actually a little bit, it's 12 volts, but it's a constant current circuit. So we'll have a look at that. It gets a little bit, it's a very interesting circuit.
But it's low voltage,
so
nothing can happen.
So as soon as that pulls that, the ECU can determine that the circuit's been open, and it'll immediately open the relays.
All right.
So then from here, as everyone, most people have had experience with this type of service disconnect, you pull that out now, and now you're disconnecting the high voltage contacts on the bottom.
Yeah.
So the point is, obviously, you've got a little bit of time at least before you disconnect the high voltage connectors. So that's the point of it. You often see that as well. So for example here, we've got these connectors here, and these are specially designed so that this connector here disconnects before the long connectors.
Okay, I see, yeah.
So that's a very special component of connectors, and that's written into the standards that has to be the case.
And just when we have a look in here as well, just as a side, and also when we have a look in here, we see there's also always a touching protection, right?
Absolutely. So that's also a part of the standards, is that you can't access the high voltage when it's exposed like that as well.
Okay, and this counts for any connection. So even it can be really at the back so that you cannot touch it.
This part here is actually what's connected to the vehicle. So we have to disconnect that one.
Yeah.
But if we have a look
it's
inside
the same case.
And you can see inside here as well the interlock in between the two cable connections.
But that's interesting here. So here the interlock has a separate connection. It's integrated in this connection or in the cable.
Always connected into the connections here.
Okay, and that's special for the AC connection.
Doesn't matter.
Doesn't matter.
If someone can access it, you can see that here. So this again is the vehicle side, and this is so we need to open it, open that up, and we again have that same action. We're pulling it up to a point. That point there has now disconnected the interlock, and then we can disconnect and you can see how it's set further back in. So that's the first thing to be disconnected.
And we have no chance to touch the high voltage line, basically.
No.
But yeah, this was again what you see really nice here, that you have here the interlock connection separated, and with this guy, it's directly integrated, right? So we don't have this. Like here we have high voltage, and here we have the interlock, and here everything runs together, right?
No, that's all. So this is also next door, so it's in between.
Okay.
It's a much smaller version.
Interesting to see.
So it's just more compact, so they're trying to make the most of the room that they have there.
But can we classically say, okay, you said these are test cables here, but what you see, and I think that doesn't make a sense regarding the color, the size or the diameter of this cable is smaller than this. So basically what is running through the AC compressor, the electric, is lower energy than what runs through the battery or anything like that.
Basically, yeah.
Because it looks a little bit lighter here than
absolutely.
that guy.
So obviously different connectors come in different sizes. It depends a lot on the voltage as well. So the voltage, as we know from Ohm's law, the higher the voltage, there's less current.
Yeah.
So if it's a lower voltage, you have more current.
Okay,
so,
I see, yeah.
You often have a lot of motor generators. So Toyota, for example, they have the buck boost converter that increases the voltage. The traction motor voltage will go up to 700 volts.
So you have a different voltage between the battery and the electric motor.
Exactly. So, but if it's running at a lower voltage, then you need bigger cables.
I see.
So it comes down to the essentially the philosophy and strategy of the manufacturer.
So you were just talking, maybe we can close that quickly. You showed how we open this one and close this one. What about this guy? So this is a little bit different, isn't it?
Exactly. So this is a component. Obviously, it'll look a little bit different on the vehicle, but you can see here it's got a little hole in there, and that's actually so you can put a padlock through there.
So right now it's opened?
Right now it's open. Okay. And the system will say, hey, that's you'll never be able to start it in this condition. And then but the padlock is here so that no one else can come and re-initialize it and start the vehicle.
What would this mean for those things when you want to make sure that no one else can re-initialize the high voltage system? Do you have to take away then the upper part which you get rid of, or how do you make the protection here?
Yeah, absolutely. So that's a good point, and you can often put that inside of a safety box.
Okay.
So put that in there. And sometimes also with the key inside the safety box as well.
And here you don't remove any part, everything is connected, and you just use the padlock in order to make sure that it can't be pushed again.
Exactly, so someone can do that, but you do need another tool so that you can close it as well. So if you just try and push it, it doesn't work. We've got some of our special little tools that we've got here, and that actually fits inside there.
Cool.
And what you can see here is that pushes out this little detent. So now we're able to do that. These are a little bit tricky. You don't just push them still though. You need to give them a little squeeze and then a push, and then everything's
And now
done.
you're good to go.
And now you're good to go.
Right. Yeah. This I think you really have to know.
Yeah.
When you try just to put it together, it won't work.
Yep. So if you want one of these, let us know. We'll see if we can make the STI available to print your own version out as well.
That shouldn't be a problem. Cool.
So that's what it looks like, but let's perhaps have a look at what the system looks like as a circuit. So
you have prepared an animation for this, I see, okay.
yeah, so we've got an animation, and you can see that on the screen now, and we've also got our Unitrain right here as well. So you can see...
BMS is for battery management system?
Exactly. So in this case, the battery management system is controlling the interlock. As I mentioned before, sometimes it's on the control module for the powertrain. Every different manufacturer does it, but essentially this circuit is always the same. So we can see the current indicated here by red going around, and we have a constant current here. So that's what I mean before. So we have a constant 12 volts, and we have a constant current of 10 milliamps here.
Okay, so it doesn't matter what happened, 10 milliampere amps are always in that circuit.
Exactly.
Okay.
So, and what we have here is different resistors. So, and we can see here, in this case, we have our, say, a cover for the inverter, our AC, so the air conditioning compressor, and the manual service disconnect on the battery itself. And that we can see here. These are the little bridge connectors that we've seen inside each of these components here, is indicated by that there. And what we have here is the voltage drop across this circuit from at the top here, so where the 12 volts is coming in, before there's any resistance. So we've got set resistors at the start and at the end here, 75 ohms. And that voltage drop across there is going to be 1.5 volts.
So that means when we have 1.5 volt, the system recognizes that as everything is okay.
Everything's perfect, exactly. So then if I go along and remove the service disconnect, we can see here now that the current has to flow through, so it's still going through the bridge connectors.
Yes.
Because, you know, electricity will always take the path of least resistance.
Yeah.
But when we take that bridge connector away, it has to go through the resistor.
Sure.
So that's a 440 ohm resistor, and that of course causes more voltage drop. And we can see that there's a difference here.
And this is measured by the BMS, and then the BMS knows which component was open, basically.
Exactly. And this is the beauty of this circuit, because we can see here we have different resistances at each of the different components. So there's a unique combination for every single thing that we disconnect here. So if you look at the voltage, here it says 6 volts. If I also disconnect the inverter, we now have 7 volts. If I put the manual service disconnect back, it says 2.5.
Yes.
So every one of these is different.
So because every resistance is different, we have for
Every voltage. Sorry, the voltage because of the resistance. Exactly.
But I just mean because we have different resistors in the interlock, so we can create, or any situation is unique for the BMS.
Exactly. So that's how your scan tool, when you get this, it will tell you, hey, you've disconnected the service disconnect. You've disconnected the battery connection from the battery to the inverter.
Just
so
one tip here again. So we saw it that it was shown like this, pulled out. But for the system, as soon as this is done, it's out of the game. So that means the interlock is open. You don't have to pull out the whole switch in that case. So therefore, we have seen that in our trainings in the recent years, that people were like, the service plug, the MSD, is plugged in, but it doesn't work. Yeah, it's plugged in, but you haven't locked it, and then nothing will work.
Classic, absolute classic, absolutely. So that's a couple of things. Let's perhaps just take a quick look at what that looks like on the training system as well.
So what we see here is our Unitrain, what we just said at the beginning. It shows the setup of a high voltage system, but on a very easy way. There is no further stuff on it. We just have the high voltage battery, the inverter, and the electric motor. And also the small guy over here, which is the MSD in that system, and it's the same what you find here basically. And what is really cool about the system, basically it behaves like a real electric vehicle. So Daniel, we can start a system and just have a look at it, right?
Exactly. So this has been a really popular training system here. We're looking at just a tiny little section of it today with the interlock, as you mentioned. but the focus here is the whole relay control side, how they're controlled. There's different types of relays, which is probably a video for another day.
Yeah.
With intelligent relays that can check to see if they've been welded shut or not. Something we can do here. The inverter is there, and then the electric motor. But what we're going to have a look at today, and so I've just brought up the oscilloscope in the LabSoft course here as well, and we're going to initialize the system as we would as well. So
start and break.
Go into ready mode. So you can hear the relays clicking on or off there, and on the screen right now you can see how the voltage builds up to the point where it can drive the electric motor.
Cool.
So if I just start the electric motor there, you can see how the electric motor is now taking off.
So we see the electric motor turning, we see how the inverter is controlled, and we see basically that the high voltage battery is connected to the inverter.
Exactly. So all of those connections, now we don't have an interlock on every connection like you do here, but we put it here so that you can at least see what that looks like. So on the screen right now, we've got 30 volts, so we're measuring here 10 volts per division, so 0, 10, 20 and 30. So this system is running on a low voltage system, so 30 volts, so it's nice and safe for everyone to use in the classroom. But ideally here, if you just disconnect the interlock there, Christian, pull it out and have a look at what happens on the screen with your oscilloscope.
I do. So we don't need gloves right now, of course.
And see, you can immediately see how the voltage has been stripped away and it's gone back immediately down to 0 volts, and the system has lost its voltage there as well.
Maybe in that case, just one word to, we saw now the active discharge, but there's also the possibility, especially at older cars or when you have a fault in the system, of the passive discharge, which just says basically how long it takes to discharge the capacitor.
Exactly.
Not the battery, the capacitor.
So that's the capacitors inside the inverter, very large capacitors that are then used to buffer the system during acceleration and deceleration, but they of course hold on to a lot of charge. So that's what everyone back in the day used to say, remove the service disconnect and then wait
10 minutes, 15 minutes.
Back when I did in the early 2000s training with Toyota, it was like, yeah, let's just wait a while. But now, of course, we need to confirm that, measure that manually, or sometimes with scan tools you can also do that now, but essentially you need to confirm and verify that the voltage is dissipated before you do that. But that's an example of...
But the standard of today from modern cars is the active discharge, where it's basically within a second that the voltage is gone.
Half a second and it's usually gone. Of course though, if you're in a workshop and you're working on one of these vehicles, there's a reason why it's in the workshop. So often if there's a fault within the system, it might revert back to passive discharge. So that's why we always verify, never assume that something is free of voltage. We always verify and check that before working on the system.
Cool, very nice. I'm just thinking about maybe we close the video with a very special case. We don't have to go in too much detail right now, but just that we have mentioned it, as this is important not only for the workshop but also for the firefighters. We can do everything here, disconnecting or interrupting the interlock, but when the relays are welded shut, we cannot shut down the vehicle, right? So all these things doesn't help us when there is a fault inside the high voltage relays and they won't open.
Yeah, exactly. So that's the relays. Some people call them contactors, system main relays, whatever it is. They're the relays that connect the high voltage battery to the rest of the vehicle, the inverter, the electric motor, the AC compressor. And as you mentioned, there are strategies that minimize the amount of current flowing to those capacitors. So we have the pre-charge circuit. But in some cases, there has been relays that are welded shut. That means there's so much current going through them that as soon as they've closed, the amount of current flowing through there has welded them shut. So that means no matter what you do with the battery, or actually not, there is something
interlock
you can do with the interlock that has no effect whatsoever then on the current or the voltage being available.
So because what it's happened, we just, that is clear for you, when we open the interlock, let's say this will trigger a signal for the BMS, and the BMS will take away the control current from the relays, right?
Exactly.
But when they are physically welded together, it doesn't has an effect of if there is a magnetic field or not in the relay, it won't open.
Exactly, and so we can see that on the screen here right now is the relays are being controlled, and they're controlled from the 12-volt side of the vehicle as well. So, but if those relays are welded closed, then that's exactly the same as being them switched on the whole time. And the only thing you can do in that case is, and this is where it gets very dangerous, and you have here in Germany, you have the DGUV on the level 3S. IMI have EV4. And that's when you're working on the high voltage battery, and you often see when you're dealing with a case like that, that's when you need the full face shield, long sleeves, the full equipment, because the danger is, again, it's now a live system, and you have to open the manual service disconnect, because as we said before, this splits the battery into two pieces. So we can see here on the video, this is our manual service disconnect here. So if we open that, that's going to break that circuit open.
Okay.
And so that's the only way you can do that. And a lot of vehicles actually don't have these anymore. The manufacturers are starting to go away from these. But exactly, they have the low voltage version, but they're trying to get away from the high voltage version. So
no contact with high voltage, basically.
No contact with high voltage. The question is, what happens if those contacts get welded shut?
That's a good question.
But the technology has changed a lot now that they obviously are happy enough that won't happen.
And you have to say, of course, in that case, it exactly happens what we said at the beginning, what we definitely want to avoid, that we disconnect a high voltage connection. But on the other hand, you have to say, when you disconnect that, you don't have a peak current on the system. So it's not like that we have then the 500 amperes, for example, running through it, as when you do acceleration or recuperation. So it's not like that you disconnect a current of 500 ampere or more.
Exactly. You want to make sure the vehicle has been shut down as best as possible, the lights, air conditioning, all those sort of things. Like you said, you're not driving around, but try and minimize risks as much as possible.
And that counts as well, not only for the high voltage technicians in the workshop, but also for the firefighters when they try to shut down the high voltage system at the site, at the accident site, for example. So all these different job groups can be affected by this fault, basically.
Yep, absolutely.
So maybe we go in another video more detail about the firefighters and all that. Daniel, I think there was a lot of information right now again. Did we miss anything?
We can continue on, but I think that's enough information for now. Let's leave that for another video.
Another video. Okay, perfect. And thank you very much for this great presentation.
Thank you.
And that you brought all this different equipment with you. I hope you enjoyed the video. And yeah, right now, we just wish you a great day and see you soon. Have a good one.
Till next time.